Okay, so in this video we're going to look at an introduction to matrices, and at the most basic level we can think of a matrix as really just a sequence of numbers that have two separate indices. So really all a matrix is, so we could say a matrix would be a sequence, say of the form A of n comma m, where 1 is less than or equal to the counter n, which is less than or equal to some stopping value, and 1 is less than or equal to the counter m, which is less than or equal to some counting value. So for example, we could have this matrix here be of n, m, and we would denote it as this sequence b of, and perhaps maybe it looks like this, b of 1, 1, comma, b of 1, 2, comma, b of 1, 3, comma, b of 2, 1, comma, b of 2, 2, and b of 2, 3. So in this case, what are our counters doing? Well, the first counter is the counter n, and so we see that 1 would be less than or equal to, so 1 is the smallest n value, and the largest n value for that first counter is 2. So that would be how the n's would be indiced from 1 to 2, and the m's, they would be indiced from, let's see, our smallest m value is 1, and our largest m value is 3. Right away we see this is kind of a clunky way to talk about a matrix, and this probably doesn't look like, if you've seen matrices before, this doesn't look like how you usually write them. So although this is all we need to be able to talk about matrices, mathematicians, engineers, everybody likes to draw them in a rectangular array. So really a better way to think of a matrix is as an n by m rectangular array. So a matrix is a n by m rectangular array. And what do we mean by that? Well, maybe it's easiest to show it. Let's take a look at this matrix that we did before, and let's go ahead and arrange it as a rectangular array. So we're going to have a total of 2 rows. So in fact the first dimension listed is the number of rows, and the second dimension listed is the number of columns. So we're going to create a, in this case, a 2 by 3 rectangular array. So it's going to have a total of 2 rows and 3 columns, and here's how we're going to organize those values. They're going to go B11 will be the first entry, B12 will be the second entry, B13 is the third entry, and then B21, B22, B23 would give us that second row. So you can think of each entry in a matrix as having sort of an address. For instance, here is the B12 entry. The 1, 2 means that we are in the first row, that's for the 1, and the 2 means we're in the second column. So this entry right here is in the first row, second column, so we refer to it as the B12 entry. So let's look at another example of a matrix. So let's let C be a 3 by 2 matrix. Okay. First thing to notice is that with matrices we almost always denote them with a capital letter. Sometimes we're clever about the way we name them. Sometimes, C might stand for the cost matrix as opposed to R for the revenue matrix, something like that. Other times we just choose the first letter of the alphabet that we come to. But we always denote them, or almost always denote them, with a capital letter. And notice that I've listed the dimensions of the matrix. Once you give the dimensions, that kind of identifies the structure. So we see that this matrix has, in this case, a total of 3 rows and 2 columns. So remember that we always list the rows first and then columns. I remember that by just RC, row by column. Like, I don't know if you remember the RC Cola or remote control, something like that, to help you remember that you list the rows first and then the columns. So C might look something like this. The matrix C might look like C11, C12, C21, C22, C31, and C32. Okay. You can't really tell by my scribbling here, those C's are actually lowercase. So when we talk about the actual entries, in fact each one of these is called an entry. When we talk about the entries in a matrix, we usually denote those with lowercase letters, as opposed to the entire matrix itself, which we denote with a capital letter. The other thing you'll notice here is when I wrote out matrix B, you can see I did it with a large parentheses, whereas when I wrote out matrix C here I did it with a large bracket. There's no special distinction between the two. Authors jump back and forth, and I will do the same. It's sort of just a matter of preference whether you're using a parentheses or a bracket to arrange your n by n rectangular array. It is worth remembering that at the end of the day, a matrix really is just an ordered sequence. There's nothing there's nothing that we require mathematically that this look like a rectangular array, as long as we've sequenced it properly, but we will always write our matrices this way. So let's look at some notation for matrices. So you might see a statement like this in the textbook or in a lecture, where we'll say let A be contained in the set of matrices that are 2 by 2 with real value entries. So this notation looks a little daunting. Let's break through it. So first of all, here's the matrix A. So we've given it its name. That's the matrix. And this symbol here, for those of you that are unfamiliar with it, that is belongs to, or is an element of. Okay. Then this is the space of 2 by 2 matrices. This whole expression here is the space of 2 by 2 matrices with real entries. So this symbol here, that's our symbol for the real numbers, that tells us that the entries in whatever matrix we're looking at are all real numbers, as opposed to complex numbers, or as opposed to functions, or as opposed to derivative operators or something like that. So we're saying this matrix has real valued entries. The expression here that's probably the most confusing is this one right here, where I say it's the A belongs to the space of 2 by 2 matrices. We actually don't know this word space yet, and we're going to take some time in this course to define what we mean by a vector space, and that will hopefully make a little more sense as the course goes along. But for right now, you could say, hey, the 2 by 3 matrices live in one place, the 2 by 2 matrices live in another place, the 7 by 5 matrices live in another place, and we want to distinguish between those places. And so that's why we denote this space here as MAT, and then we give the dimensions for that space of matrices. Okay, so let's look at a couple of examples that might belong to this. For example, A could be the matrix that looks like this. So what does C here? We said it has to have 2 rows. That the first index there says we're going to have 2 rows and then 2 columns. So let's see, maybe matrix A looks like 1, 2, 3, -4, or something like that. Notice that all my entries here are real valued. Or maybe A looks something like 1.5, square root of 2, 0, and 4/3. Notice here again, all the entries in the matrix are real valued. Another thing that's a common mistake people do when they first start working with matrices is they will try to separate the entries in the rectangular array with commas or something like that, and we're not going to do that. Just by positioning, this is the first entry. For example, this entry right here is the 1, 2 entry, and we know that we don't need to separate, we don't need to put any extra commas in or anything like that. This is in the first row, second column. So it does mean you have to be careful in lining up your rows and columns as you write out a matrix. Okay, let's look at one more example. So we could say, let's let B be an element of the matrices that have dimensions 1 row by 3 columns, and let's say the entries come from the complex number system. So this sort of strange looking C here stands for the complex numbers. So again, let's say this one more time. What does this 1 denote? This denotes that we have 1 row in our matrix and we have 3 columns in our matrix. So what could matrix B look like? Matrix B might look something like I plus 3, and 7. Number 7 can be thought of as a complex number. It can be thought of as the complex number 7 plus 0i. Or maybe B would look something like -3, I, and the square root of 2 minus 3 square root of 5i, or something like that. So notice that both these matrices that I've denoted B, they have 1 row with a total of 3 columns in them. So this is a quick quick overview of what a matrix is. What we're going to start doing now is we'll return to this idea of the space of matrices, and we'll start looking at what operations can we do with matrices. We're going to learn how to add two types of matrices together. We can't add all matrices together. We're going to learn how to do something like matrix multiplication, and we're going to learn a few other operations like the matrix transpose and scalar multiplication. So stay tuned in the following videos.